Hello student, now this is the video for the maths part 2, chapter number 2, parallel lines. In this video, we will learn the use of properties of parallel lines, test for parallel lines, interior angle test theorem, alternate angles test theorem and the corresponding angle test theorem, and also lastly, we will solve the practice set 2.2. Now let us start the practice set 2.2. Now let us start use of the properties of parallel lines. Test for the parallel lines, interior angle test, alternate angle test, and also we learn the corresponding angle test also. And lastly, we will start the practice set 2.2. Now let us learn use of properties of parallel lines. Let us prove a property of a triangle using the properties of the angles made by a transversal of parallel lines. Means that here we will prove that the sum of measures of angles of triangle is equals to 180. And this is very important theorem. The sum of measures of all angles of a triangle is 180. Given triangle ABC is any triangle. Measure of angle ABC plus measure of angle ACB plus measure of angle BAC is equals to 180. And in this figure, this is a triangle ABC. Now here we make the construction. What is that construction? Draw the line PQ parallel to BC. As PQ is a parallel to BC, AB is their transversal. Then the angle PAB is congruent to angle ABC as they are alternate angles, and the angle QAC is congruent to angle ACB. These are, and here is an angle BAC. Now let us start. Draw a line parallel to segment BC and passing through A. On the line on this line we will take the point P and Q, such that the point A is between P and Q. Now the line PQ is parallel to BC, AB is their transversal, therefore the angle ABC is equals to angle, measure of angle ABC is equals to measure of angle PAB, ABC is equals to measure of angle PAB. This is one, that is alternate angles. Line PQ is parallel to BC and the AC is that here transversal. Next, angle ACB, measure of angle ACB is equals to measure of angle QAC. Again, these are the alternate angles. This is the statement number 2. Now, if we add these two statements, then we will have, that is a measure of angle ABC plus measure of angle ACB here. To the right hand side, measure of angle PAB plus measure of angle QAC. And now here we will add one more angle, that is a measure of angle BAC. This is measure of angle BAC. Now we have added the measure of angle BAC on the both sides. Therefore, measure of angle ABC plus measure of angle ACB plus measure of angle BAC. These are the angles of the triangle. Now here on the right hand side, measure of angle PAB plus measure of angle QAC, measure of angle QAC plus measure of angle BAC. Now here we'll bring here, that is a measure of angle BAC here, and if we add these two angles, that is a measure of angle PAB plus measure of angle BAC. If we add these two angles, then we will get the measure of angle PAC. That is the angle addition property plus measure of angle QAC. And if we add the measure of angle PAC plus measure of angle QAC, then we get the linear pair angles and their sum is equals to 180. And that's why the measure of angle ABC plus measure of angle ACB plus measure of angle BAC is equals to 180. And here is the sum is equals to 180 because the angles in the right hand side are the linear pair, and hence that is the sum of the measures of three angles of a triangle is 180. That is, we have proved here. Now let us discuss here. If in figure, how will you decide whether the line L is a parallel to line M are parallel or not? Now we'll derive for that the three theorems. Now in this figure, line L is a parallel to line M. Then how to decide whether they are parallel? For that we'll derive this theorem. Test for the parallel lines. Whether given two lines are parallel or not can be decided by examining the angles formed by a transversal of the lines. If the interior angles on the same side of the transversal are supplementary, then the lines are parallel. Now in this figure, here is a line L and M, and this is their transversal. If we add these two interior angles, and if their sum is equals to 180, then the line L is parallel to line M. This is the interior angle test. Now next, if one pair of alternate angles is a congruent, then the lines are parallel. For the parallel lines, now see this is a line, these are the two lines, this is a transversal, these are the alternate angles. If this pair is congruent, then these given lines are parallel. In same way, these are the different types of the figures. You can see this. Now next, if one pair of corresponding angles is a congruent, then the lines are parallel. In this figure, angle 1 is a congruent to angle 5, and these two lines are parallel. Similarly, other angles are also shown in this figure. Angle 2 is a congruent to angle 6, angle 4 is congruent to angle 8, angle 3 is a congruent to angle 7. Now next, interior angle test. This is the theorem, that is if the interior angles formed by a transversal of two distinct lines are supplementary, then the two lines are parallel. Means sum of the interior angles is equals to 180, then the lines are parallel. Now first is given, line XY is a transversal of line AB and line CD. Measure of angle BPQ plus measure of angle PQD is equals to 180. Then the line AB is a parallel to line CD. Now in this case, we are going to prove, we are going to give an indirect proof. That is, let us suppose that the statement to be the proved is wrong. What we want to prove that? Suppose that is we want to prove that line AB is a parallel to line CD. This we want to prove, but that we assume that this is wrong. Means what? The line AB is not parallel to line CD. Now then what will happen? That is, we assume that line AB and the line CD are not parallel. If these two are not parallel, if we extend these two lines, they will meet each other at the point T. That is, it means that the line AB and the line CD intersect at the point T. Then what will happen? Here is a triangle PQT. Now the measure of angle TPQ, measure of angle TPQ plus measure of angle PQT plus measure of angle PTQ is equals to 180. That is the sum of the angles of a triangle. But we have given that is a angle TPQ plus measure of angle PQT is equals to 180. We have given here, and that's why if this happens, measure of these two angles is 180. What about the measure of this angle? Then the measure of angle PTQ will be 0. That is a line PT and the line QT, means line AB and the line CD are not distinct lines. It means, but we are given that the line AB and the line CD are the distinct lines. We arrive a contradiction. Therefore, our assumption is wrong, and hence line AB and line CD are the parallel lines. Thus, it is proved that if the interior angles formed by a transversal are supplementary, then the lines are parallel. Now, once again, you see that first we assume that our assumption is wrong, that is the lines are not parallel, then they will meet each other at the point T. then we take all the measures of this triangle, that is 180, but we have given that angle in the given, that is the angle TPQ plus angle PQT is equals to 180. It means that PTQ is equals to 0. Then it indicates that the line PT and the line QT, that is a line AB and the line CD, are not distinct, but we have given that AB and CD are the distinct, and we arrive at a contradictions, and hence our assumption is wrong, and hence line AB and the line CD are the parallel lines. And in this way we have proved this is the property called the interior angle test for the parallel lines. Now next, alternate angle test. If a pair of angles formed by a transversal of two lines is congruent, then the two lines are parallel. Here the line N is a transversal of line L and the line M. Angle A and the angle B is a congruent pair of alternate angles, that is angle A is equals to angle B. If these alternate angles are congruent, then the lines are parallel. That is, the line L is a parallel to line L, and this is called the alternate angle test. Now here, that is, we want to prove that line L is a parallel to line M. Now see this in this figure, A and C, these are the linear pair angles. Angle A and angle C are the linear pair angles. Therefore, measure of angle A plus measure of angle C is equals to 180. But also, angle A is equals to angle B. Angle A is equals to angle B. This we have given. Therefore, in place of this angle A, we will replace here angle B. That is a measure of angle B plus measure of angle C is equals to 180. But what type of these two angles are? Angle B and angle C are the 180, and their sum is equals to 180. It means that these are the two lines, and these B and C, these are the alternate angles, and their sum is equals to 180. It means that the line L is a parallel to line M by using the interior angle test, and hence this is the property is called the alternate angle test for the parallel lines. Then what is again? I will revise this. When the alternate angles are congruent, then the lines are parallel. This is the test for the alternate angle test. Now third is a corresponding angle test. It means that is if the corresponding angles are congruent, then the lines are parallel. If a pair of corresponding angles formed by a transversal of two lines is congruent, then the lines are parallel. Here line N is a transversal of line L and the line M. Here angle A is congruent to angle B. This is we have given. Angle C and angle A, these are the linear pair angles. And again we will write here, that is the angle A and angle B are the congruent pairs of corresponding angles. Angle A is equals to angle B. What we want to prove that the line L is a parallel to line M. Therefore, angle A plus angle C is equals to 180. A plus C is equals to 180 because they are the linear pair. But we have given that A is equals to B. Therefore, we will replace here C by A. That is we will replace here A by C. Therefore, measure of angle B plus measure of angle C is equals to 180. Again, I will repeat here. That is we replace here A by B. Therefore, measure of angle B plus measure of angle C is equals to 180. But B and C are the interior angles. Again, by the interior angle test, and these two lines are parallel, and hence the line L is a parallel to line M. That is a interior angle test, and this is the property called the corresponding angle test for test of the parallel lines. Again, I will revise that in a short. That is, when corresponding angles are congruent, the lines are parallel. Now the next, corollary 1. If a line is perpendicular to two lines in a plane, if a line is perpendicular to two lines in a plane, then the two lines are parallel. If you take the two lines in a plane, same plane, and draw that line, and that line is parallel perpendicular to that two lines, then the lines given in that planes are parallel. For example, that is here given line N is a perpendicular to line L, and the line N is again perpendicular to another line M. Then that is a line L is a parallel to line M. This is a proof. Now line N is a perpendicular to line L. In this figure, line N is a perpendicular to line L, and again the line N is a perpendicular to line M. Now see this here. Here the measure of angle 90 and the 90. These are the corresponding angles. As these are the corresponding angles, they are the congruent, and hence line L is a parallel to line M. This is very simple. Angle A is equals to angle C is equals to 90. Measure of angle A, measure of angle C, both are the 90, and as angle A and angle C are the corresponding angle, it is formed by the transversal N of the line L and the line M. Therefore, the line L is a parallel to line M, and by using the corresponding angle test, we prove that the line L is a parallel to line M. Now the next, corollary 2. If two lines in a plane are parallel to a third line in the plane, then those two lines are parallel to each other. Now in this case, line L is a parallel to line M, and line L is a parallel to line N. Then we will prove that line M is a parallel to line N. Now see this here. The line L, M, N are the coplanar lines, means they are in the same plane. Line L is a parallel to line M. Line L is a parallel to line M. Line L is a parallel to again this line, third line N. What we want to prove that line M is a parallel to line N. Now we'll prove this. This is a proof, that is to prove line M is a parallel to line N. Now we have given that the line L is a parallel to line M. As these two lines are parallel, angle X and angle Y are the corresponding angles. Therefore, angle X is congruent to angle Y. These are the corresponding angles. Next, line L is a parallel to line N. Line L is a parallel to line N. And again, angle X and angle Z. These are the corresponding angles and they are the equal. Now see this here. Angle X is congruent to Y. This is 1. Angle X is congruent to angle Z. Therefore, angle Y is congruent to angle Z. As angle Y is congruent to angle Z, therefore, by the corresponding angle test, line M is a parallel to line N, and hence in this way we prove that is the line M is a parallel to line N. Now we'll start the practice set. Now the practice set 2.2. In figure, Y is equals to 108, X is equals to 71. Are the lines M and N are parallel? Justify. Now in this figure, line L is a transversal of the line M and N. X and Y are their interior angles. X is equals to 108 and Y is equals to 71. If you add these two angles, then you will get X plus Y is equals to 179, which is not equals to 189. If the interior angles formed by a transversal of two distinct lines are supplementary, then the lines are parallel. But here their sum is not equals to 180. That is, a line M is not parallel to line N, as it does not satisfy the interior angle test for the parallel lines. Now in figure, if angle A is a congruent to angle B, then the line L is a parallel to line M. Actually, these are the exterior alternate angles, but we will prove here. Now see this here, solution. In this case, line L and M, that is N is their transversal. We want to prove that line L is a parallel to line M. Now see this here, measure of angle A is equals to measure of angle C. These are the vertically opposite angles. And again, angle B and angle C, these are the corresponding angles. Their measures are equal. As A is equals to B, A is equals to C. Therefore, B is equals to C. Now consider here as angle C as shown in this figure. A is equals to B. This we have given. A is equals to B. Next, A is equals to C, vertically opposite angles, and hence B is equals to C. And therefore, by the corresponding angle test, line N is a parallel to line M. It's very simple. Also, these are, I had say that these are the exterior alternate angles also. Next, in figure, if angle A is congruent to angle B, angle X is congruent to angle Y, then prove that the line L is a parallel to line M. Now see this figure. In this figure, this line K is a transversal for the line L, M, N. First angle B and angle A, these are the corresponding angles and they are the congruent. Therefore, the line M is a parallel to line N. Next, for the line L, M and N, the line K is a for the line M and N, this line is a transversal and the angle X and angle Y. These are the alternate angles and they are the congruent. Therefore, the line M is a parallel to line N. Now here, line L is a parallel to line M. M is a parallel to line N. That is, the first is parallel to second, second is parallel to third. It means that first is parallel to third. That is, line L is a parallel to line N. This we want to prove. We will write here, from the figure, angle A and angle B are the corresponding angles formed by the line L and M and the transversal K. Angle A and B are the corresponding angles. A is equals to angle A is a congruent to angle B. Therefore, the line L is a parallel to line M by the corresponding angle test for the parallel lines. This is first. Angle X and angle Y, these are the alternate angles for the line M and N. That is a angle X is congruent to angle Y. It means that is a line M is a parallel to line N, and this is by using the alternate angle test. Now in these examples, we are using the two tests. One is a corresponding angle test and another is a alternate angle test. Here, that is a line L is a parallel to line N, M is a parallel to line N. It means that line N is a parallel to line M, and in this way we have proved it. Now the next example. In figure, if ray BA is a parallel to ray D, angle BCD is equals to 50, angle D, here is angle D, that is equals to 100. Find the measure of angle ABC. Measure of angle ABC. Now here we have given the hint. Draw a line passing through the point C parallel to line AB. That is, from this point C, we will draw a line through the point C, and that we'll name it. That is a line FG is a line which is a parallel to AB. It's also parallel to D is also. Now see this in this figure. Draw a line FG through the point C and parallel to line AB. This we have given. Now ray D is a parallel to ray BA. D is a parallel to BA. This is we have given. And BA is a parallel to FG. BA is a parallel to FG. This is the construction. It means that all these three lines are parallel. That is a ray DA. DE is a parallel to ray BA, is a parallel to line FG, Again, see in this figure, ray DE is a parallel to ray BA, is a parallel to line FG. Now the next, measure of angle EDC is equals to 100. Measure of angle EDC is equals to 100. Now see this here, as DE and FG are parallel, DC is their transversal. Therefore, the measure of angle, that is again I will repeat, the ray DE is a parallel to line FG, line DC is their transversal, angle EDC and the angle DCF, these are the alternate angles. Therefore, I had shown here in the red lines, that is the measure of angle DCF is equals to 100. Therefore, line D is a parallel to line FG. DC is their transversal. Therefore, measure of angle EDC, measure of angle EDC is equals to measure of angle DCF, and therefore measure of angle DCF is equals to 100. DCF is equals to 100. This is 100 here. Next, a measure of angle DCB plus measure of angle BCF is equals to DCF. That is the angle addition property. Now see this here. Measure of angle DCB plus measure of angle BCF is equals to measure of angle DCF, and that is equals to 100. But we have given this measure of angle DCB, that is a 50. Therefore, 50 plus measure of angle BCF is equals to 100. Therefore, measure of angle BCF is equals to 100 minus 50, and therefore measure of angle BCF is equals to 50. Here is the measure of angle, here is a 50. Now this total angle is 100 and this is a 50. It's clear that measure of this angle is 50. Now next, ray BA is a parallel to, now ray BA is a parallel to line FG, BA is a parallel to line FG, and BC is their transversal. Therefore, measure of angle ABC plus measure of angle BCF is equals to 180. As these two lines are parallel, sum of their interior angles is equals to 180. Now see this here, measure of angle, this is 50 degree. Therefore, measure of angle ABC, we'll substitute here, measure of angle ABC plus BCF is 50 degree is equals to 180. Therefore, measure of angle ABC is equals to 180 minus 50 degree. That is, measure of angle ABC is equals to 130, and hence that is the measure of angle ABC is 130. This is the answer. Now the next question, number 5. In figure, ray AE is a parallel to ray BD. Ray AF is bisector of angle EAB, and ray BC is the bisector of angle ABD. Then we want to prove that AF is a parallel to a line or the ray BC. Now here, ray A is parallel to ray BD. Ray AE is a parallel to ray BD, and the line AB is their transversal. Therefore, angle EAB, measure of angle EAB, is congruent to measure of angle ABD. These are the alternate angles. That is, angle EAB is equals to angle ABD. Multiply on both sides by 1 upon 2. Therefore, half of EAB is equals to half of ABD. Half of EAB is equals to FAB. It means that half of this EAB is equals to FAB. And the next half of the ABD, that is equals to angle ABC. This angle ABC. But angle FAB is equals to angle ABC. These are the alternate angles for the ray AF and the ray BC, whose transversal is AB, and therefore by the alternate angle test, that is a line AF or the ray AF is a parallel to line BC using the alternate angle test. A transversal EF of line AB and line CD intersects the lines at point P and Q respectively. Ray PR and ray QS are parallel and bisectors of angle BPQ and PQC respectively. Then we'll prove that the line AB is a parallel to line CD. In previous examples, we proved that the bisectors are parallel. Now in this example, these two lines, we are proving these two lines are parallel. Now see this here, again I will repeat here. These two bisectors are parallel. Now we want to prove that line AB and line CD are parallel. Now, as these two bisectors are parallel, PQ is their transversal. Now we'll take here the alternate angles. See this here. Ray PR is a parallel to ray QS we have given. Line PQ is their transversal. Therefore, angle PRQ is congruent to angle PQS. Uh, Again I will repeat. That is angle RPQ is a congruent to angle SQP. Now see this here. SQP or PQS. These are the two angles. They are the congruent. Now that is a angle RPQ is a half of angle BPQ. RPQ is half of the angle BPQ. Therefore, RPQ is half of the BQP and the angle PQS. This is PQS. It is a half of the angle PQC. It is a half of the angle PQC. Therefore, as these two angles are equal, therefore these two are also equal. Their right hand sides are also equal. Therefore, the half of the BQC is equals to half of the PQC. We can cancel on both sides. That is the half and half. Then we will get that is a measure of angle BPQ is equals to measure of angle PQC. Now these are the alternate angles for the line AB and line CD, where PQ is their transversal, and by alternate angle test the line AB is parallel to line CD. Now see this here. The angle BPQ is equals to angle PQC. They are congruent. Therefore, the line AB is parallel to line CD by the alternate angle test. And in this way, we have completed the chapter number 2, parallel lines. I hope that you would have understood all the problems, whatever that I had explained. Now we'll see in the next video. Till then, goodbye.